Today, thank you for accepting our participation in your conference. A comparative study between two main method, perturb and observe, and the other method, incremental conductors and PPT techniques for PV integration in electrical vehicle battery using RTLab. So, why electrical vehicle? Electrical vehicles are becoming increasingly important to their potential to reduce greenhouse gas emission, improve air quality, and decrease dependence on fossil fuel. Of course, there are other reasons that we should use these EVs in our life, but why not? Of course, this will have a problem. This problem is the storage system, the autonomy, and the battery charging time. So many research try to increase the autonomy and decrease the battery charging time. And for us, we'll try to develop the electrical drive system, the motors, the main back boost chopper, inverters, mode of control, and even try to integrate PVs. This is our drive system. You can see we have the battery banks, the power converter. In our case, we have back boost chopper and the motor drive that drive the motor. This is the main light of our system. This is the main system. We have a battery, a chopper, back boost chopper, and another chopper because we will choose a DC motor, and the integration system of the PV and an auxiliary supply. The main system work in two mode of control, the boost mode of control and the regenerative mode of control, braking mode of control, of course. And this is due to our DC-DC converter, and this is the back boost chopper, the main back boost chopper, that maintain DC bus that drive by the DC-DC converter that drive our motor. Why we choose a DC motor? Of course, to control the speed, we just have to control the voltage, and to control the torque, we just have to control the current. And this is too simple. And this is not true for all electrical motor. Let's come back to our system. This is the PV, and we will use another converter that ensure the MPPT. Why MPPT? You can see the EV curve. We have many main points like the short circuit current and the open circuit voltage. You can see that if we increase the voltage, we will increase the power until one point that decrease. So we will get this point, and in this point, we will have a VMP and EMP, a voltage maximum power and a current maximum power. MPPT stand for maximum power point tracking, and it is a technique used in photovoltaic systems to optimize the power output of the solar panels. And MPPT charge control, in our case, it will be chopper, adjusts the operating parameters of the PV system to ensure that it operates at its maximum power point that we have seen in the curve under varying conditions, sunlight conditions. This is our system. You can see this is the PV and the electrical vehicle. We have a boost converter because the voltage of the electric vehicle is more greater than the PV. We will have two sensors to measure the voltage and the current, and calculate the power. On this measure, the MPPT controller will change the duty cycle to control the output voltage. Let's talk about the perturb and observe MPPT technique. So we will have, of course, we have an algorithm. We will have an initial value. This initial value will measure the voltage and the current to measure the power. It's P1. Then we increase the voltage. It's P2. We will calculate delta P. If delta PV is positive, so we are in this region, so we will increase the voltage. If delta PV is negative, so we are in this region, so we will decrease V until we will get delta PV equal to 0, so we will get the MPP. For the incremental conductance, we will calculate the derivative of the power instead the voltage, or delta P delta V. If delta P delta V is positive, so we are here, so we increase the voltage. If it is negative, so we are in this zone, so we will decrease the voltage until we will get delta P delta V equal to 0. So this is the maximum power point, MPP. Opel RT, well, why we use this Opel RT is a device used in many area, in many fields, power systems, power electronics, automotive, aerospace, and this instrument is in our laboratory. Many customers use it, like Toyota, Hyundai, ABB, even in the aerospace, even NASA. So it is a very important device. In the rapid control prototyping, we will use the instrument, the RTLab, that work in MATLAB, of course, with a laptop. We have a laptop and RT Opal software to control the real hardware. We have three main type of real-time system configuration: pure simulation. We have the controller and the plants in the simulation, real-time simulation, and we have hardware in the loop. So the controller is real to control the simulation plants. And for the rapid controls prototyping, the instrument, the RTLab, control the plant. This is our simulation. This is the battery, the back boost chopper that maintain the bus current to an fixed voltage, and we have here our 4-current chopper that drive our motor. This is the integration voltage. You can see PV and the boost chopper and the battery. Our PV have maximum power almost 130 watts, and we have the characteristic point like open circuit voltage and short circuit current. You can see in the validation power results for like in the incremental method, we get the maximum power. It's 130 watts is the maximum power that be supplied by the PV, and it takes like 0.05 seconds. For the perturb and observe results, we can see that we have more fluctuation, but it gets the maximum power, but it's slower because it takes 0.15 seconds. For the duty cycle, you can see that to get the duty cycle, the maximum duty cycle, at the same time for the power, even for the incremental method and for the perturbation and observe method. But it fluctuates more in the perturb and observe method. It fluctuates open around 0.68 for the incremental method, and it fluctuates around 0.7 about the perturbation and observe method. So we will not have the maximum voltage to get the maximum power. For the state of charge, the SOC validation result, you can see that our battery is charging for the two method, but for the incremental, it's slightly more better than the perturb and observe. As conclusion, both methods were found to be capable to tracking the maximum power point MPP of the PV panel during the RTL validation process, but the perturb and observe method respond a little bit more slowly than the incremental method. Both methods control the back boost chopper, the boost chopper duty cycle, which regulates the power delivery, and the better approach and the incremental approach are showed that we have a stable duty cycle fluctuation that guarantee that the boost chopper would deliver a correct voltage to the battery. The incremental method approach marginally outperform the perturb and observe method if we will see the state of charge. Thank you.